For the rest of this section, we're going to take a look at hypothesis tests comparing two means. And a lot of times we just want to see if there's a difference between two means. So this hypothesized value is 0, and so this would be 0 here. Sometimes we might think the hypothesized value is a certain difference. For example, maybe I think that not only do males have a mean height that is greater than the mean height for females, I might think it's a 5-inch difference, and so my hypothesized value here might be 5, for example. Notice the test statistic is not too difficult here. We have sample standard deviations. We have to incorporate both sample sizes. And since this is a t-test, we need to use degrees of freedom to figure out what value to read off the table to get our p-value. If you don't have a calculator handy, then it's best to go with the more conservative value for degrees of freedom, the smaller of the sample size -1. So let's take a look at an example. In this particular problem, we're going to see if bounty towels are the stronger picker-upper, and this particular problem describes how the students collected their data, how they have a random sample, and how their data collection methods were the same for both paper towels. And the numbers we have listed here, the 30 numbers for each of the paper towels, are the number of quarters the paper towel could hold before ripping, and this is when the paper towel is wet. So the first thing you want to do is enter the data in your calculator so that we can look at the data in parallel box plots. So at this point, Mrs. Neville, if you can pause the video so that the students can enter the data in their calculators, that would be great. So you can see that I have the data entered in list 1 and list 2 in my calculator, and I'm going to create a pair of parallel box plots. So I'll turn plot 1 on, and the type I've chosen here is a modified box plot, and we're going to choose list 1. So that's okay. Do the same thing, hit second, stat plot, turn plot 2 on. Once again, I've chosen the type modified box plot, my data is in list 2. I'll quit out of there and then choose zoom, option 9, which is zoom stat. So we can see that this box plot at the top here is for list 1. So this is my bounty data, and notice the minimum value for bounty is 103, and if I come down here, the maximum value for the generic brand was 103. So these plots really don't even overlap. Just the minimum and maximum values are where these overlap, and this maximum value is actually an outlier for the generic brand. So I'm thinking we're going to find a statistically significant result in the difference of the population means. Not just statistically significant, but very, very significant, in fact. And if we wanted to see how significant or how big the difference is, we could even calculate a confidence interval if we chose to. So let's go back to the problem. Let's use our significance test to determine if there really is convincing evidence, which I think there is, that bounty paper towels can hold more weight on average than the generic. So we had a random sample in both cases here, and our sample sizes were both 30, so we didn't have to worry about the population distribution being normal in either of these. So I can just go ahead with that. I don't have to worry about doing a normal probability plot or checking for outliers. Even though there were outliers in the generic paper towels, those don't matter because our sample size was 30. And actually it's greater than or equal to 30. And it's reasonable to assume that we did not sample more than 10% of the population. So I want to see if bounty can hold the same number of quarters on average as the generic. I'm going to choose an alpha equals 0.05 level. My degrees of freedom is 29. And I suspect that bounty, since it's the name brand, it should be, at least I would hope it would be since you're paying more money for it, it should be stronger. It should hold more. The average number of coins held by the bounty paper towels will be more than the average number of coins held by the generic. So you can either write your alternate hypothesis this way or this way. And then here's our formula. Where we need to go to get the values for the sample means and sample standard deviations is back to our calculator doing a one variable statistic on both those lists. So once again, Mrs. Neville, if you could pause the video so that the students could see if they can get those values to substitute into their calculator. And once they have those, we'll see if they can get the correct value for the test statistic. So you should have done a one variable statistics on both list 1 and list 2, and these are the values you should have gotten. For the sample mean for Bounty, it was 117.6 coins, and for the generic brand, 88.13 coins. I'm guessing these are coins that are the same size. You wouldn't want to use dimes on one and pennies on the other. And then we have our standard deviations of 6.64 coins and 6.296 coins. So this is the exponent here squared. Sample sizes were 30 for both. So our test statistic is 17.64, and if you look at your t-table, that is like not even on the charts of the t-table for degrees of freedom for 29. The p-value is essentially 0. So we would reject the null hypothesis. Wet Bounty paper towels can hold more weight on average than wet generic paper towels. As a matter of fact, quite a bit more weight. Assuming they were to hold the same weights, it would be almost impossible to get these results, or even something more unusual by chance alone. Let me show you real quick how you would do this on your calculator. To do the hypothesis test on your calculator, you would go to Stat, Tests, and you would choose to sample t-test, not a z-test, a t-test. We are using the data that we've already entered in list 1 and list 2, and we think Bounty, which was in list 1, is stronger than the generic brand, so I'm going to use greater than. Once again, pooled, choose the option no, calculate, and notice our test statistic is very small, about 3 times 10 to the negative 25th power, and our test statistic value is 17.64. If you have any questions relative to what you learned over the past 2 days, please don't hesitate to send me an email. I will be checking my email on Tuesday evening and Wednesday evening as well.